Yaskawa.
Multitasking is one of the major functional advantages that MotionWorks IEC Pro has over MotionWorks IEC Express. And so in this segment, we'll start with a short overview, and then we'll show how to create a new task, what the different task types are, and when to use them. We'll give an example of a system task and also a high-speed scan task. We'll cover the concept of a program instance and task priority, as well as I/O task. And I'll be using examples and demonstrations for all of this. First, as an overview, before we get into the software, here are some vital stats about multitasking. And the first is that we can have up to 16 tasks running in the controller. Each task can have a different interval, which is like the scan time. For example, the tasks that are used to control motion, you would want to have a fast scan time, as fast as the Mechatrolink update rate. Also, each task has a priority, so that you can set the most critical tasks to run first in the sequence. Also in Pro, we will have to get accustomed to the fact that when we make a new POU, a program POU, we'll need to assign that manually to one of our tasks. And again, I'll be showing all this by means of an example. And then also, when you add hardware to the system, such as a servo pack or an I/O card, you'll have to choose a task that the I/O will synchronize with. And again, I'll be demonstrating and illustrating all of these topics here as we go along. So we have multitasking. How do you insert a new task? It's really easy. You right-click Insert Task right on the task folder under the controller. I'll demonstrate that with this zipped project that I have prepared. In this case, I do have the zipped project where I want the project to unzip to, so I'll click Yes. And I'll skip the firmware libraries again and overwrite the page layout. We're ready. Okay, now my project is open. And this is a similar project to what I've been demonstrating in the other parts of this training. This is a project that was converted from an Express project. And so if you go down here to the physical hardware, see under my physical hardware, I have in the configuration one resource, which is the MP2300 SIEC controller. And that controller is running tasks which are in the task folder. And since this was an Express project, there's just one task, a cyclic task named task, which is running all of the POUs. All of the program POUs are running in this task. And also you can notice that this is a cyclic task, not only because it says cyclic, but because of this circular green arrow icon. We'll keep an eye on that. We'll see that different tasks have different icons. So I right-click on the task folder, Insert Task. I'm presented here with this dialog, and the first field is easy. It's the name. I'll call this task Startup. And I'm calling it Startup because I want to have a task that will run one time when I power up the controller. And the only other option you have here is the task type. If you pull down this list, you can see there's 4 options. And so as long as we're looking at this now, let me explain what these 4 options are. The first in the list is default. Now the default task type is what you'd call a low priority task. And basically that means that if the controller has nothing else to do, it will default to running the program POUs that are under the default task. The default task is not synchronous in any way. There's no scan time to set, and this is also referred to sometimes as the background task. Now you might want to have eventually a default task set up just for those background type of calculations, maybe a cam table or a recipe calculation that might take a while to complete, but really doesn't have to complete within a certain amount of time, or a calculation that doesn't have to be calculated over and over again within a certain synchronous cycle. Cyclic tasks are the type you're probably most familiar with. They repeat at the given interval that you'll specify, which is popularly called the scan time in the PLC industry. And once you choose the cyclic type, you can set this interval. Cyclic tasks are what you'll use to run the bulk of your machine code. And so you can put POUs that run the most critical part of the code, such as the motion blocks, into the fastest tasks, and the less critical code, such as user interface, could run in the slower tasks. And additionally, we'll see later, you can set the order in which the tasks run, which often will mean that the fast motion related tasks, you want those to run first. And I'll be doing an example of a cyclic task, a fast cyclic task, after I finish up this startup task. The next one in the list is the event type, and the event task runs based on interrupt conditions such as the state of an input. The only thing about event tasks at the time of this recording is that it's currently under development, and so we'll be offering that at a future date. Many times the event that you need is really a system event, and so in that case you would choose the system type of task. And what this means is that the task will run just once when the system reaches a given state, such as a power on. And so for this task named startup, I'm going to need a system task. So back to the software, I will choose system and click OK. And if I pull down this drop-down list, you can see all of the different system settings that could be used. There's warm start, which is the power on. There's also cold start, program stopped, watchdog error, which will come up later, and some of the other errors. If you're not sure what these are and you're curious, just go ahead in the software and click on the help, and then after you click on help, look in the table for SPG number and click on the link here for system programs, and you'll see a little bit more information on all of the possible system tasks. So I'll close that for now. So for a startup task, which would run when you power up the controller, that's a warm start, SPG 0, probably the most common system task that you'd use, and I'll click OK. And you can see that puts in the task list now another task. So just to summarize, for the system tasks, you can use those for warm start, cold start, and any number of errors. Now, making tasks is a good place to start, but you also need to have program instances running in those tasks. So if you look back at my example, I have the startup task now, which is a system type of task, but there is no program POU under this task like there is under the cyclic task. And so if you already have the POU running and it's already in a different task, you can kind of shuffle these around. And so for example, this init, if I don't want this in the cyclic task, I can just simply drag it up to the startup task, and that's it. And this is because I already had the code for init. If you want, we can look at that here quickly. It's just a couple of variable declarations. So now those will run one time at startup, running under the init task. This is important because if you don't have any program instance under a task, you'll get this compile error, missing program instance in whatever task that has no instance. So you have to have an instance in here. And you can either move it from a different task or you can create your own. And so to create your own, maybe I would like to have another POU. I'll call it init2, insert program. And maybe this one is a ladder diagram. Maybe I'm going to be initializing outputs, let's say. So I could call this init2. Click OK. I'm not going to do actually any programming here. But notice init2 did not go to any task. So init2 is a POU, but it's not going to be running in the controller. If I want to have it run under this startup task, I'll need to manually add that. And that's what's called adding a program instance. So if I right-click on the startup, insert program instance, I can now give it an arbitrary name. I'll just call it init2. Doesn't have to be called init2, but that makes sense. And then the program type is also init2, and that's alphabetized here in the list. So I have a new POU, program POU, and so I'll choose program type init2, click OK, and that puts init2 in the list. So now when I'd have a startup, it's going to run the ladder code in init2 and the structured text code in init. And it will run them in this order. So if for some reason I want to be sure that init runs before init2, I will need to click and drag to put init1 to run before init2. And finally, it's a good idea just to do a make to be sure that everything is fine. And I have 0 errors and 1 warning, which is the empty worksheet warning for the init2 worksheet. Next are the cyclic tasks. And as I've mentioned several times, just because it's so important, the power of multitasking is that you can create fast and slow tasks to optimize your code execution so that critical motion-related POUs run fast and the non-critical user interface POUs can run slowly without hogging all of the processor power. So back to my project, let me make another POU task, and this time I'll make it as a cyclic task. So you right-click on the task folder, insert task. I'm going to call this name fast, and the task type will be cyclic. I'll click OK. And this brings up the task settings for this cyclic task. By far the most important setting here is the interval, and so let's give a few rules here for the interval. The first is that you can set it as low as the Mechatrolink cycle time. And so back in your hardware configuration, if you go to the Mechatrolink area, you'll see the communication cycle by default is 2 milliseconds. So using the default values, 2 milliseconds is the lowest that you could go with the interval. Of course, if you were to lower the Mechatrolink communication cycle, you could also then lower the interval of your task. Additionally, we recommend that you set the interval of your task as a multiple of the Mechatrolink 2 communication cycle time. So for the default, as a setting of 2 for Mechatrolink 2 cycle time, you'd have 2, 4, 6, 8, etc. for the interval setting. Now you also see fields here for priority and watchdog. Let me skip ahead to watchdog first. The watchdog simply sets a processing time maximum so that if on any given cycle it's taking too long to process the code, then the controller will fault with a watchdog error, which also can be handled by a different system task that you'd have to make. So what we recommend is that you set the watchdog time to match the interval, or it could be slightly lower. Task priority is another basic setting that deserves consideration when you're using more than one task. The priority is a number you give the task that tells the processor sequentially what order to begin processing all of the tasks. It's kind of like a number on a waiting list. So 0 priority is first, and 31 is the highest number, which would be the last. Typically, you'll want the critical tasks with the fast scan times to execute first, that is with a low number, and then the slower tasks to execute later. So back to my task settings here in the software, I can set the interval for this fast task to 2 milliseconds. I would like the priority to be 0 so that it's the first task to execute. And then I'll follow the rule here of setting the watchdog time equal to the interval, and I'll click OK. So now I have 2 cyclic tasks. One of them is called fast, one of them is called task. And you can always go back into those properties by right-clicking to the settings. And you can see that on the other task here, the interval is 10 milliseconds, but the priority is also 0. So here's where, if I want to be sure that my new task labeled fast happens before this task I had before, I'll need to increase the priority number on the original task. So I'll set that up to 1, and then that will ensure that my fast task is always the first one to execute. And I'll click OK to accept that. And now finally, this fast task needs some POUs to be executing in it. So I'll take what I consider to be the critical motion tasks, such as cam, put that into the fast task. I'll take positioning, which also controls motion, and I'll take gear and put that also in the fast task, while leaving the main, the servo on, the monitor, the control logic, and the homing program POUs to operate in the original 10 millisecond task. And I'll finish this off with a make. I got my 0 errors. And now finally in this segment on multitasking, let's look at the I/O task assignment. And the I/O task assignment is done within the MotionWorks IEC hardware configuration. The program POUs may be the only item you see in the task list, but nonetheless, the hardware I/O is also running in one of the tasks. So we can open up the hardware configuration to see which task the I/O is running in for each device. So we'll start the hardware configuration. And so by using this hardware configuration utility within Pro, you can further tweak your system so that the critical I/O are synchronized with a fast task and your non-critical I/O run in a slow task. The idea is, why spend processor time updating and writing the I/O that doesn't really need to be updated that often? So the servo pack has an I/O. So if I go to an SGDV, I'll go to the I/O tab, and you'll see at the bottom the I/O task assignment. It will be assigned to whatever it was assigned to by default. In this case, it was assigned to the task, since this was, again, a project imported from MotionWorks IEC Express. And so I can choose for this servo pack whether I want to synchronize the servo pack's inputs and outputs with the fast task that I made, the startup tasks that probably wouldn't be advisable unless you weren't using them, or the original task, that 10 millisecond update. And there's also selection for background, which is like the default task, just updates it when it can. So I'll leave this one set to task. You can also see the LIO card I have on this configuration has an IO task assignment. This one's been set to the background. Maybe I don't want to do that. I would rather have that go to, let's say, the fast task. If I have critical I/O within this card, I would want to choose fast. And you can also see in my configuration I have Modbus, and Modbus and Ethernet IP also have an I/O task assignment. And so if you have a Modbus extended I/O over your Modbus or TCP IP, you can set the task assignment here. And if I can also set the I/O task assignment here to fast. Additionally, you might notice here there's this update interval. And so it doesn't make any sense to have your update interval at 50 milliseconds and then synchronizing that to a 2 millisecond task. So what you can do is, if you want to have your network I/O, either Modbus or Ethernet IP, if you want to have that synchronized with Mechatrol Link, you can assign it to a 2 millisecond task like I've done here. Assign the update interval also to 2 milliseconds. I can right click, modify, set that update interval to 2 milliseconds. And now with my Mechatrol Link update also at 2 milliseconds, I basically have Modbus I/O updating at 2 milliseconds. So I'll save that. And of course I would need to connect and save that to the controller and cycle power if I was online. So I'll close this. Now I skipped over one important point here, which is that there is a special task called the I/O task, which is created by the template, which can be chosen and will be chosen by default when you start a project in Pro. And let me just show that. So I'll save what I have here and do File, New Project. Choose the template, you click OK, and you can see with the template I have the I/O cyclic task and the task cyclic task. Just a quick look at the settings, and you'll see 10 milliseconds for the original task, and for the I/O task, settings are 50 milliseconds with priority 7. And if I were to open the hardware configuration on this new project, you can see that if I were to add a node, such as a servo, it will ask me not only what node number, but it'll ask me what task to synchronize the I/O with. And so you can choose the I/O task, or background. And so that's just one option you have there. If you want to just use a 50 millisecond cyclic task, I/O task is what you'll get. And I'm offline here. If I were to connect to the controller and pull in that auto configuration, it's going to automatically configure the I/O task synchronization to this specially generated I/O task. But please don't think that you need to use the I/O task for your I/O. This is just a default so that when you do have a new project, your I/O does run on a task. You're always free to come in here to the configuration and then update that through the I/O tab and change that task to any of the other tasks that are available. And so this concludes the multitask section of this presentation. And I hope that with this information demonstrated, you will be able to create your tasks, set your program POU instances to the appropriate tasks, and then also set your I/O, each to their appropriate task, to run your machine with the highest performance possible.